this is the assembly we had completed in our past lecture. So here if you see, these are all rigid joints. Let us see how a cam actually works so that we understand what we are trying to accomplish in this lecture. So when this cam rod rotates, okay, the cam follower should actually go up and down based on the rotation of the cam. So this is the operation that we want to give to our present assembly. So I'm just closing this old file. So in our file, we will try to accomplish this. Now, if we see, first of all, we have to make this cam rod flexible. That is, it should rotate. So let me first check which joint it is. So you can see here, this is my joint, which should actually not be rigid. So here I'm going and right clicking and say edit joint. Then instead of making it rigid, here I have motion option. I will make it revolute so that it can revolve. You can see now how it is revolving. Okay, so I can animate and see my motion which I have given. Then click OK. So now when this revolves, because this has rigid joint, this also revolves that way. We can see that this symbol has changed to revolute, and from here if I drag this one or if I change the value of this one, I will be able to revolve this, and I can see how the associated parts also revolve along with it. Here we have a rigid joint, so this is also revolving along with that. So now if you see here, these two portions are going to interfere because when this is revolving, this has a rigid joint. So this will stay there. So what we can do is we have to give a sliding motion to this. Let us delete this rigid joint and let us assemble it once again. So let us assemble from to this point to this point. For that, I'm selecting joint, capture position, and I will say that this part should be at this top part, right? And we should be able to rotate it by 90. Okay, and I do not want this to be rigid, so in motion I'm selecting slider so that it keeps sliding. Okay, but what if it slides beyond this, right? It shouldn't. So for that, there are two ways I'm going to use to arrest this motion. One is contact sets. Contact sets helps us in avoiding interference. That is, if you see now, this is going through that material, but contact sets tells it that there is a material and it has to stop there. The other way is to give the distance of how much it has to travel, how much limit it can travel. So for that, first we will be applying limits. For limits, we can go to slider, say edit joint limits. Now, how much maximum it should go? Let us first calculate. I'm just clicking cancel. Go to inspect, and from here to here, how much distance is it? Let us measure. So this distance is this distance. Till this point it is 50. And this distance is 5 mm. We know that this is at 5 mm. So that is, the distance would be 45. And till here, from here to here, now the distance will be minus this 5 also. Okay, so it will be 40 mm. So right click and edit joint limits. So maximum it can go 40 mm, and we also know that if this distance is 40 mm, this whole thing will be 20. Minimum will be 20. That is, I'll show you how. Before that, let me cancel this. Now here, I'm going to keep this angle as 270 so that this goes up. Then click enter. Now we'll try to measure this distance. Go to I from here to this place. So it is 25. Minimum is 25. Here you can see the minimum distance is 25. But again we have this plank, so it will be 20. Now right click and say edit joint limits. Minimum it should go 20 and maximum it can go 40. Right? So now let us see the animation. This seems okay, then I'll click OK. Now we have to give another condition that these two should not actually interfere with each other. So when this is going down, it should rotate, or we can say that when this is rotating, it should go up, because that is the only degree of freedom left. So for that, now what I'm going to do is I'll go to Assemble and click here, Enable Contact Sets. Now we get this in browser. Right click and say New Contact Set. For new contact set, I'm selecting follower and this cam. So these two will never interfere now. So this will not go beyond that. So now you can see how I have got this. So if this is going to come up, it will move upside because that is the only degree of freedom left. And when this is moving down, because this also cannot interfere with this, and this is the only degree of freedom this cam has, so it will move in that direction. Right? But now the cam in real life, if you see, due to gravity, this should actually always be in touch with this. So how do we do that? For that, what we can do is we can say that it should always rest at 40. Right? So whenever we say it is at 40, even though we are sending it up, when we send this down, it will automatically come down with it. But it will see to it that it does not interfere with that. For that, right click. Remember we had put edit join. Now we will say that it should rest at 40. Then click OK. Now let's rotate this and see. Okay. So here I have this rotation handle. So you can see when I'm raising this up, it is going up because it should not interfere, but because it always has to rest at 40, it is trying to come down without again interfering with this cam. So this motion we have created in Fusion 360.